Welcome guys to my video lesson today. In today's class, I will be teaching you a topic called nuclear fusion and nuclear fusion. I'm going to be explaining, okay? Now, if you are a student preparing for JAM or XSE or post-UME or nursing or any external exam, please, I would like you to subscribe to my YouTube channel and also on your notification bell so that whenever we post video, you will be notified. Now, let's dive into what we have for today's class. Today's class is nuclear fusion and nuclear fusion. Now, these two terms are terms used in radioactivity. Okay, now the nuclear fusion and the nuclear fusion are subtopic of radioactivity. So now let us look at this carefully. What is a nuclear fusion reaction? They are actually chemical reactions in radioactivity. What is a nuclear fusion? A nuclear fusion reaction is a type of nuclear reaction that involves a heavy radioactive isotopes being broken down to give us two or more lighter nuclei of nearly equal masses with the release of energy and what? Radiation. Yeah. Is the process by which a heavy radioactive isotope splits to form two or more simpler or lighter nuclei of nearly equal masses with the release of energy and what? Radiation. Now, what do I mean by this? In this particular radioactive reaction, a heavy isotope such as uranium, yes, such as uranium-234 92 uranium, such as uranium. This uranium is a heavy radioactive isotope. It becomes broken down into two or more lighter nuclei. Do you understand? Yes. But how would this happen? This uranium will have to be bombarded with a subatomic particle called neutron. So I'm going to add neutron to this reaction. Neutron is a subatomic particle found in the nucleus of an atom. Okay, now if I add this to this, something will definitely happen. And what will happen is that this radioactive isotope, now this guy uranium, will be broken down into two or more lighter nuclei. Now this nuclei will be what? The first guy will be barium with a mass number of 140 and atomic number of 56. Are we together? Okay. Now the second particle that will be emitted will be krypton. Krypton with an atomic number of 36 and a mass number of 92 thereabout. Okay, now if we have this and this, do you know what will happen? This process is actually an economic process because it yields more neutrons. Yes, we will now have what we have 3 moles of neutron. So you must understand that in a nuclear fusion reaction, it begins with 1 neutron but end up giving us 3 neutrons. Take note of that. This is your neutron. Now we have 3. We started with 1, but we have 3. Let's see whether the equation is balanced before we proceed. The total mass here is 234 plus 1, 235. Okay, 235 in the left hand side. In the right hand side, we have 235 as our mass number, like this. But let's combine 140 to 92 plus 1. You know this one, there are 3 in number. So you have 140, 92 plus 3. Okay. So here you have 5. This you have 13. Put down 3, carry 1. Here you have 2. So you have 235. 234 plus this one will give us. So the equation is what? Balance. 92 plus 0 is 92. Let's combine 56 and 36. Here is 0. So let's say 56, 36. This will give us 12. Put down to carry 1. And then 8, you have 9. So the equation is what? Balance in a nuclear fusion reaction. Now, these guys are the what? Product. You will discover something that what we have here is a heavy isotope. A heavy radioactive isotope. That's what we have here, a heavy radioactive isotope. But in this place we have lighter or simpler, yes, lighter or simpler radioactive isotope. You must note this. So in the nuclear fusion process, a heavy radioactive isotope is broken down to what? a lighter or simpler radioactive isotope. Now, class, I want you to note this. In nuclear fusion, you must understand some facts here, class, that this particular reaction leads to what we call a chain reaction. Yes, it leads to a chain reaction. It leads to a chain reaction. It leads to a chain reaction. Please note this. What is a chain reaction? A chain reaction is a type of reaction where the product form serves as the new reactant. Yes, where the product form serves as the new reactant. What do I mean by that? Now, this neutron is bombarding the uranium to give us these two guys, okay? Now, due to the fact that more neutrons are produced, this one will further bombard barium and krypton, and more of what? Lighter nuclei will be formed. And when this happens, energy will be what? Emitted. Energy, which we refer to as nuclear energies, will be emitted. Energy, or you can use radiations, will be emitted. Now, the energy continues to what? To be emitted or produced through this process. Why? Because this guy, which is the product, will now become the new reactant, and the neutron keeps bombarding it to generate more product. And the more you break these atoms, the more energies are released. So a chain reaction is a type of reaction where the product that is formed serves as the new reactant to produce more product. Now, because of the energy release in this process, it has what we call various applications, which we refer to as the application of nuclear fusion. You will know it, just stay calm. Applications of nuclear fusion. What is the application of nuclear fusion? Number one, it is used in a nuclear plant. Used in a nuclear plant. Nuclear plant. A nuclear plant is a giant plant or a giant machine that is used to convert chemical or nuclear energy into electrical energy. It is used in advanced countries to generate electricity. Okay, so we can say using a nuclear plant to generate electricity. Yes, to generate electricity. How? By simply converting waiting chemical or nuclear energy, chemical or nuclear energy, which is the energy in radioactive substance, to what? Electrical energy. This must be noted. So, ladies and gentlemen, gentlemen and ladies, dear Jambites, now, in one of the applications is what? It is used in a nuclear plant to do what? To generate electricity. Okay, now, when you look at this, the way this nuclear plant is designed, you will discover something about this nuclear plant, that it has various component parts, and these component parts have their various functions, for which JAM will test whether you have an understanding on this particular subject. So take note of this important alert. Take note of this alert. Alert number one, that you are likely to see in your JAM exam or your SSC exam or other related exam, is this. You must understand that the fuel in a nuclear plant, the fuel in a nuclear plant, the fuel in a nuclear plant is what? What's the fuel in a nuclear plant? Is uranium. The answer is uranium. Uranium-234. That's the fuel in a nuclear plant. Take note of that. Number two, what are the moderators in a nuclear plant? The moderators. The moderators. What are the moderators in a nuclear plant? I have told you that the applications of nuclear fission is one is used in a nuclear plant to generate electricity. So we are talking about the functions of the component parts. The moderators in a nuclear plant. A nuclear plant. What is the answer? The moderators is simply what? Here's the answer, class. Graphite and heavy water. Yes. The moderators in a nuclear plant are graphite and heavy water. What is the function of the moderators? The function of the moderators is to slow down fast-moving neutrons. Yes, to slow down Not to stop the process, please, but to slow down fast moving neutron. Fast moving neutrons. Yes, because the neutrons are in high speed, moderators are usually added to slow down the fast moving neutron. Please, it must be noted. Take note of this. Yes, take note of this. It must be noted. Okay, so you understand this. Understand this. Now let's get into soft stuff here. Do you know that we have control rods? Yes, there are rods in the nuclear plant. The rods are called the control rod. These control rods are used to stop the process. Please take note of that. The control rods are used to stop the process. By the time the energy generated is sufficient and is enough, the process has to be paused or stopped using the control rod. So what are the control rods? The control rod, please take note of that. Let's do that quickly. Control rod that stops the process or stops the neutron is what? Please take note. The answer to this question is cadmium, and boron rod. Please take note of this. It should be noted. Listen, the moderators are used to slow the process down, not to stop the process. So we use graphite and heavy water to do that. But to stop the process or to stop the neutron for further reaction, we use cadmium and boron rod. Please take note of that. Take note of that. Now, take note of this. Take note of this. Now, do you know that when the plant becomes hot, very, very hot, you must use a cooling agent to do that. Okay? So take note that liquid sodium, in case you sit in your exam, liquid sodium and what? Water are used as a what? Cooling agent. To what? To cool the plant. It should be noted. It should be noted. Now, more also, class, take note of this point. This. It is very important. The walls of nuclear plant are built with iron, concrete, and sheet metals. Take note of that. The walls of nuclear plants. The walls of nuclear plants are built with concrete. Take note of that. Concrete, iron, and concrete and iron. Take note of that. And sheet metals. Take note of that. The walls of nuclear plant are built. This is to do what? To minimize energy loss. So it must be noted. The number one applications of nuclear fusion is what? In the production of nuclear plants. Yes. Then the second application is that it is used in the manufacturing of atomic bomb. Take note of that. Used in the manufacturing of atomic bomb. It should be noted. So take note of this fact, okay? Now let's go over to what we call nuclear fusion. Okay, I just did a summary on nuclear fusion. So let's go to nuclear fusion. Let's do that quickly. Nuclear fusion, okay, we have is the process by which two or more lighter nuclei or simpler nuclei, this time is the opposite, combine together to form a heavy nucleus. Yes, with the release of what? Energy and radiation. So in this case, two simple nuclei join to form a heavy nuclei. Let's take a look at this. The name of this guy is called deuterium. Yes, this is deuterium plus tritium. These are lighter nuclei. Take note of that. Lighter nuclei. Lighter nuclei. They will join together to form a heavy nucleus, which is what? Helium. Helium plus Now, if you have 2 plus 3, you have 5. And here is 4. So you're probably to have neutron here. Yeah, neutron. So this is helium. Now, these light nuclei join together to form a heavy nuclei, which is what? Helium. This is what we call nuclear fusion. You are combining 2 or more simpler atoms to give you a heavy atom, like you have on the board. So it's quite very cheap, okay? Now, what is the application? Application. Number 1, don't forget that this guy is called deuterium. Deuterium. This one is called tritium, and they are both isotope of what? Hydrogen. Yeah, they are both isotope of hydrogen. So 2 isotopes of hydrogen join together to form helium plus neutron. Now, the application is this. Number 1, use in the manufacturing of hydrogen bomb. Used in the manufacturing of hydrogen bomb. Very important. 2, the sun derives its energy from this process. This is the application of what? Nuclear fusion. Now, let's consider atomic bomb and hydrogen bomb. Please take note. Don't forget that when we talked about nuclear fusion, we said that it is used to make atomic bomb. Yeah, take note of that, please. It is used to make atomic bomb. Then we'll talk about nuclear fusion. We'll say it's to make what? Hydrogen bomb. It has been proven that your hydrogen bomb produces more energy than the atomic bomb. So take note that hydrogen bomb energy is greater than atomic bomb energy. So the energy produced by a hydrogen bomb is greater than the energy produced by atomic bomb. Now, listen. Remember when I was teaching you the components, the function of the component parts in a nuclear plant? I said that the nuclear plant, the walls are built with concrete, sheet metals, and what? Iron. Yes. The walls of the nuclear plant can also be built. Yes, it is also built with lead. Take note of that. Don't forget that lead is the best absorber for radioactive ray. I've told you before in my previous video when I was teaching radioactivity part 1. So the walls of nuclear plants can be built with lead, iron, and concrete. Take note of that. Concrete. So the walls of nuclear plants are built with lead, iron, and what? Concrete. Not just concrete and iron, but also lead. And take note that lead is the best absorber of radiation. And you must know that the purpose of building with these guys is to minimize energy loss. Thank you very much. I'll see you in my next video. Subscribe for more.